This is based upon a presentation that I gave to Dunn Humby in April of this year. Managing a complex world from innovation to commoditization. I'm going to explore this subject from the particular viewpoint of managing enterprise architecture in IT. To set the scene, a quick review of industry literature shows that the average CIO needs to align IT to the business, to keep up with the latest trends, to focus on core activities whilst providing good governance, which means detailed planning. You have to keep it adaptable and flexible, not forgetting secure, whilst being cost efficient and innovative and providing a good return on investment. You also need to look into software as a service and utility computing, and Web 2.0 and Web 3.0 and Enterprise 2.0, and don't forget business process execution language, modeling notations, TOGAF, open source, and on and on and on and on. It can sometimes even feel like the rest of the business is not always on your side. Well, today we're going to explore what's causing this. My name is Simon Wardley and I work and speak in the open source and Web 2.0 communities. So I thought I'd introduce myself with a tag cloud of my passions. Now, if you look carefully, you may notice that I like ducks. That's because I've got a pond at home with lots of them. I think ducks are great, unlike turkeys, which I can't stand. Now, I'm a scientist by training, so I always want to understand the processes behind any change. So we're going to look at the driving forces behind all this noise, namely commoditization and innovation. We're going to start by defining what commoditization is and how it is impacting our industry. We'll then examine innovation and develop a framework for how stuff happens. I'll then use this to explain why nothing is simple in management before leaving you with some predictions for the future. Before I start, a few words of warning. If there is anyone here with a design background going, is he using Comic Sans? Well, yes, I am. I know I shouldn't be using it. I know it upsets designers, and you'll just have to forgive me. Now, this session should last around about 45 minutes, and I'm going to try and complete it with 385 slides. I know what you're thinking, but I like to experiment, and in any case, there will be plenty of signposts along the way. So that ends the words of warning, and we'd better start with commoditization. What is it? Well, the formal definition is change from monopolistic to perfect competition. But I prefer, in plain old English, yesterday's hot stuff becomes today's boredom. Or alternatively, how something exciting, novel, and new grows up to become something that isn't. So what drives commoditization? Well, in the world of business, when someone invents something new, then if it's useful, everyone tries to copy it, until eventually someone releases a product, and then finally, with enough demand, you have a common or a utility-like service. There is a constant pressure towards commoditization as everyone tries to take advantage of a new idea. A good example of this is electricity. Now, back in the 1890s, electricity rocked. It was hot stuff. Really, really hot stuff. Electricity mattered. For your average forward-thinking businessman, it provided new competitive opportunities. You could replace expensive labor with shiny new machines powered by electricity. It was an exciting time for the different forms of electricity, from static to dynamic to even therapeutic electricity. Yes, electricity was a powerful constitutional tonic, according to the American Electrotherapeutic Association of 1892. Of course, in the hands of the amateur, it could have disastrous consequences. Nevertheless, it was exciting and new, and electricity was the stuff the future was made of. By 1904, we had invented the plug, and by the 1930s, the national grid. Electricity was common. It had lost its spark. Electricity was yesterday's hot stuff. And that's commoditization for you. It's an ugly word for a beautiful process that creates new opportunity. For example, you need easily available power, data processing and communication before you can have the new stuff like Google. And as Joseph Schumpeter explained, and I won't ask you to read this, the impulse that keeps the capitalist engine in motion is the new stuff, a term known as creative destruction. Now, when something is new or rare in business, we call it a potential source of competitive advantage. When it is common, necessary, and ubiquitous, it is described as a cost of doing business. So back in 1996, websites were novel and new. IT made a strategic difference. IT created a competitive advantage, which was great. Until Paul Strassman pointed out that much of IT didn't. Apparently, all that was happening was one big arms race, with companies wanting ever bigger and better IT than competitors. And of course, every time a company got some new big gun, like an e-commerce site, all its competitors followed suit. And if you weren't armed, you had problems. Much of what we considered to be a source of competitive advantage in 1996 is now ubiquitous and common. It has no strategic value. It is at best a cost of doing business. Web 1.0 has become yesterday's hot stuff. Today it's all about the new stuff. But then that's always been the case. So let's recap. Using the examples of the electricity industry, we've talked about the constant pressure towards commoditization as everyone tries to take advantage of a new idea. We've mentioned how this creates new opportunities, a concept known as creative destruction, and how commoditization is occurring in the IT industry. Now I'd like to look at how this impacts the IT industry. To do this, we need to first look at how we build stuff. Whenever we build an application, we repeat a lot of stuff we've done before, like install the infrastructure, common components, a framework, and then afterwards we generally scream at the incompatibility issues. To give an analogy, if house builders built houses like software engineers built software, then for every house they would build a power station, a sewage works, and several factories. And they would also scream at the incompatibility issues. Of course, it would be mad to build houses like that, and unfortunately they don't. Builders have been doing mashups for centuries, combining commodity-like products and services such as bricks and waterworks to build property. In IT, we are only just starting to learn how to use commodity or common services to build new things. Whether it's with a service-orientated architecture, using common internal services, or combining internal and third-party services, or even applications that mash up different services, or application services maintained by third-party providers. We're getting more used to building with services and dealing with environments where our systems may run on someone else's infrastructure, such as Amazon's EC2. We are starting to learn the art of service architecture, something the builders have been doing since Marcus Vitruvius Polio, author of De Architectura, suggested that you don't build a brand new aqueduct for every villa. Obviously, as this field is new, there are a plethora of different terms, from virtualization to grid computing, from service-orientated architecture to software as a service. Now, back when I was at school, my happy school days, my science teachers used to always say, before exploring a subject, get some definitions sorted, some simple images of concepts. So let's go through each of these terms. Service-orientated architecture, at its simplest, is an architectural style for building with services. In other words, every house doesn't need its own power station. Virtualization is a technique for abstracting physical hardware. In other words, you get power from a plug. You don't need to know what's behind it. Grid computing is a technical architecture for collating computer resources. In other words, it's a national grid rather than a single power station. Utility computing is simply a business and provisioning model. In other words, it's a meter. Software as a service is merely a delivery model. In other words, rent rather than buy. Obviously, these services can be combined. For example, a service-orientated architecture may include some software services from third parties, which might be charged for on a utility basis and built on a computing grid that uses virtualization technology. It's all early days, we're still learning. One area which I take a particular interest in is software as a service, or SaaS. Now, if we examine a software stack from the application to the framework to the hardware, then software as a service is merely about the commoditization of a product-based economy to a service one. It's about a transfer of responsibilities from consumer to vendor. So let's recap. I've talked about commoditization and how yesterday's hot stuff becomes today's boredom. We've covered how there is a constant pressure towards commoditization as everyone tries to take advantage of a new idea. We've looked at how this can create new opportunities, which are the underpinning of our economic system. We've looked at how wasteful the process of building something in IT is and how new tools and techniques and architectures can help solve this. And I specifically mentioned the commoditization of the software stack from product to service. I now want to turn my attention to what innovation is and to develop a framework for how stuff happens. So far, we've described commoditization as the change from something new to something common. Now let's ignore most of it and shift it to the side. And whilst we're here, we may as well call a new thing what it really is, an innovation. Okay, so we've got innovation to commodity, but how do we get to innovation? Where do these innovations come from? Well, I have an idea that their origin is in an idea. Okay, but what's an idea? I need some simple definitions. Step in, John Locke. According to John, an idea is a term which best serves for whatsoever is the object of understanding. Sounds good. Let's add that to our framework. Okay, but how do you get from idea to innovation? Okay, step in Jan Fagerberg. According to Jan, innovation is the first attempt to carry out an idea into practice. Okay, I can see a slight problem. Who was the first person to create a wireless radio? Well, of course, As we all know, it was Nikola Tesla. Okay, how about who created the first usable electric light bulb? Yes? Of course. The answer is Sir Joseph Wilson Swan. Let's try an easier one this time. Who flew a kite into a stormy night in order to show that lightning was made of electricity? Got it yet? Why? And of course it was Thomas Francois Dalibard. How about the first powered controlled sustained air flight? Got it? Yes, of course, it was Felix de Temple. The problem is, who was first? As Elliot Sibowicz said, whenever you prove who was first, the harder you look, you will find someone else who was more first. So let's modify Yann's law. To innovation is the first-ish attempt to carry out an idea into practice, and let's add that to our framework. Now, we can go from idea to innovation onto commoditization, which is great. But where do those ideas come from? Well, that is a tricky subject. At the beginning of the 14th century, the conventional wisdom was that those ideas came from God. This was challenged by Francesca Petrarch, and the new old wisdom was that those ideas came from invention and discovery. Now, not everyone agrees with this, but let's assume it's right. I'm not expecting anyone here to be from the Spanish Inquisition, but if there is, then please complain to Petrarch. He's dead. So now we have an idea of how innovations turn up. For example, someone discovers global warming. Someone has the idea of using economics to solve the problem, and someone puts this into practice or innovates with tradable carbon permits. We now have a framework for how stuff happens, from invention to commodity. Okay, a number of things I wish to note with this framework. One, it is not a straight line. As I said earlier, commonly available services allow for new things to be created. So there is feedback. Unfortunately, I'm a rubbish graphics designer, so my attempts to draw this were awful, especially when I added pictures. As with all rubbish graphics designers, I just took a screenshot, added it to my graphics package, and pressed all the buttons I don't understand. And hey presto, the result was a mess. However, I'm going to use this anyway as a metaphor to explain that the process is not linear but complex with some cyclical aspects. 2. The framework is not just about physical things. I use the example of electricity, but I could equally talk about the spread of a management theory, such as Taylor's scientific management or Davenport's process engineering. 3. Not everything spreads. Some things only get so far. Why? Lots of reasons, from physical constraints to not being that useful. 4. Acceleration. Now, there are a number of known accelerators to this process, from network effects, where an innovation becomes more useful the more people adopt it, to the internet, to standards, and even to the open sourcing of technologies. Point 5. Friend and foe. Commoditization can reduce non-strategic costs through economies of scale. Now this will make any businessman happy, but there is a sting in the tail. Let's suppose I'm a news provider dispensing news to the masses. Now, a cost of doing business activity is distribution. Well, the internet has reduced this until it is so low that my once passive consumers can broadcast news for themselves. The cost of doing business stuff also acted as a barrier to entry, a barrier to participation in this industry. Hence, commoditization can therefore increase competition. So let's recap. We've covered the constant pressure towards commoditization and how this is impacting the IT industry with the growth of software as a service. We've discussed how such commoditization allows for new opportunities, and we've taken a look at where such new stuff comes from and where it doesn't. We've created a framework for how stuff happens. We've noted it's not a straight line. It's not just about things, and not everything spreads. We've also noted that whilst there are accelerators, there are also unintended consequences. Now, I want to use this to explore why nothing is simple in management in order to create some predictions for the future. To do this, I'm going to have to create a geographical representation of our framework. As I said, I'm not much of a designer, but I am a scientist, so I like graphs and equations, and I haven't used any today. I know what you're thinking, but I thought I'd give in to a bit of temptation, a bit of what I call science porn. Okay, first we need to know what we're going to graph. What I want to look at is organizational activities. So we're going to need a simple definition for activity. Activity is a process or a sub-process or a result thereof, including any product or service consumed or created. Now, to make my life easier, I'm going to use a Roger Everett's S-curve for the diffusion of innovation as a base for my graph. Let's get started. I'm going to start by first mapping out the axes. I'll have one axis, which I'll call Ubiquity, from something novel, like a good film with Tom Cruise, to something common, like a film with Tom Cruise. The other axis we'll call Certainty, from something which we don't know how to solve, like how to build a working time machine, to something which we do know how to solve, i.e. is highly certain, like what is 1 + 1. Now, I'm going to quickly step into some of my research and add some real data to this. This is phones 1920 to 1990, TVs 1930 to 1985, and VCRs 1985 to 2000, plotted against definitions of ubiquity and certainty. It follows an approximate S-curve shape. Now, this isn't a predictive graph, as both the definitions of certainty and ubiquity have to be passed in order to map the relationship to avoid something which is called asymptotic behavior. However, this merely shows and illustrates that an S-curve relationship exists. So I can use my Everett's S-curve of innovation. So let's now add an activity to our graph. I'll start with something which in the 1980s was relatively unknown and novel: computer-based customer relationship management systems, or CRM. Now, at this time, such systems were so rare and the field so unknown that we didn't even have a name for it. Now, by the mid-80s, a number of companies were building CRM-like systems, often called database marketing. By the early 90s, the first CRM products started to appear. There are even more books on the subject. It's becoming more common and more well-defined. This decade, we've seen utility-like on-demand CRM services. The subject matter is far more ubiquitous and defined, from best practices to conferences to white papers and so forth. CRM has gone from something which was novel and unknown and innovation to something which is commonplace and well-defined, more like a commodity. From innovation to commodity, from hot to not. So let's look at the characteristics of something which is hot. Let's pretend to create an innovation. Now let's give our innovation a good marketing name. Let's call it Web 3.0. Well, when it's new, there is a scarcity of information about it. There are no good case studies on Web 3.0. It's also poorly defined. No one actually knows what Web 3.0 really is. There are few competitors. I'm not sure anyone is using Web 3.0, and it generally costs a lot of money. As in, hello, I'm a Web 3.0 consultant. Now, when it comes to managing such an innovative activity, then since by very definition it must be different from what already exists, deviation is a good thing. It's new. It can't be the same as the old stuff, otherwise it wouldn't be an innovation. So processes designed for change are most suitable, hence agile methods are good for innovative pursuits. Furthermore, as a new thing, it has the potential to be a source of competitive advantage, a differential between you and another. Now, since no one knows how much it is going to cost, you should focus on worth and value, a VC-like approach to funding. Now, let's look at something which is more of a commodity, like a telephone. Well, here there is a wealth of information on telephones. There's probably a book, My Favourite Telephones in History. In fact, there is a book, Telephones in History. Also, how to use one is fairly well known and defined. Most of your competitors have telephones. It's not a differentiator. They are generally low cost and they're mass produced in a repeated process. Now, when it comes to managing your telephone system, deviation from normal operation is not a good thing. If I'm installing a telephone system, I want a rigorous and well-defined process. It's not like it's never been done before. Also, since it's a cost of doing business, I want it as cheap as chips, as cheap as possible. It's worth remembering, however, that the telephone was once novel and new, and hence expensive, undefined, and so on. The characteristics, therefore, of any activity changes from innovation to commodity, and hence so does the means of managing it, even though whatever it is remains the same. Things aren't simple. So let's make some general observations. We will start with methodologies. Now, if you take a snapshot of all the activities within your organisation, you will find that most of them are somewhere on that curve, and they are moving. Some are innovations, most are commodity-like. Now, what happens when you decide to create a blanket policy for your organisation? Let's say you decide you're going to use Six Sigma everywhere. Well, it's a good, solid methodology. And this will benefit those commodity-like activities by minimizing deviations. However, this will also harm these innovations. The thing to remember is you need to use different methodologies for different stages of an activity's life cycle. Okay, observation 2, outsourcing. Now, despite a wealth of organisational theory, from classical to systems, we have a tendency to organise by function, with each function containing common activities. IT deals with IT and marketing deals with marketing. However, if you look at a single function, you'll find that it contains a mass of different activities at different stages of their life cycle. So let's consider the outsourcing of a function such as marketing. Ideally, what we want to outsource is the commodity-like activities, where economies of scale and standards can exist. What we don't want to outsource is the innovative and transitional activities, where there are no economies of scale. To outsource this would be to hand over a future source of profit to a third party. Outsourcing by function can be costly and is inefficient. Okay, observation 3, vendors. Now, most technology vendors want consumers to perceive their product as innovative, a source of competitive advantage, exclusive and high value. Whilst at the same time, those same vendors want the products to have a wealth of information, case studies, many consumers, and to be low cost to produce and maintain. Generally, vendors want a difference between what something is and how it is perceived by the consumer. This perception gap is generated by activities such as branding and marketing. Fourth observation I wish to make is about the organisation itself. Rather than outsourcing by function, I should really outsource by activity lifecycle. In much the same way, I don't want to apply methodologies across a function. I want to apply them by activity lifecycle. Now this begs a question. If we need to vary so much by activity lifecycle, why do we organise first by type of activity? Why don't we just organise by activity lifecycle? Why don't we have innovation, transitional and commodity functions? Why do we group by IT, finance and so on? The answer to this is history and habit. We've also lacked the tools to really question how we organise ourselves, from wikis to participation architectures. This is all changing with Enterprise 2.0. However, it should be noted that there is a tendency for organisations to prefer activities in this quarter of the activity graph, well defined, well understood and with a little variation in inputs. Why? Well, because these activities are, according to Ashby's law of requisite variety, simpler to manage. We have a tendency to try and apply simple, well-defined control mechanisms across all our activities because it makes it easier to manage them. It's a lot harder to manage complex or chaotic systems. Unfortunately, our desire for simple order brings us into conflict with the paradox of innovation, that whilst we need order to survive today, we need disorder to create a future. This brings me on to observation 5, order and disorder. Organisations are a mass of different activities undertaken by a number of people or actors. Now, if you remove these activities and actors, you are left with what an organisation really is. Nothing. Organisations only exist in the interaction between people and activities. However, people and activities are in constant state of flux. People leave. Activities change, whether you change or whether they change in the outside world. This means any organisation needs to continuously adapt to outside changes in order to retain its relative competitive position. This is the business equivalent of the Red Queen hypothesis from genetics. In other words, you need to adapt in order to survive today. But you also need to innovate in order to survive tomorrow. Organisations are therefore a constant exercise in rebuilding. Well, fortunately, we know some people who have lots of experience of doing this. And one of the key architectural principles of effectively rebuilding is to use common stable components. Now, there is a formal proof for this in the theory of hierarchy, part of the cybernetic school of management. However, for our purposes, it's suffice to consider that whilst any business might contain some competitive activities, you hope so, it also contains some cost of doing business activities or commodity-like activities. As we've already noticed, commoditization allows for new services to be built. So ideally, we want these cost of doing business stuff to be in some form of service architecture that can be quickly recombined to build new innovative services. It's actions like this which can help overcome the innovation paradox between order and disorder. It's why lots of people are very excited about mashups plus service-orientated architectures. So let's recap. I've talked about commoditization and how this is happening in our industry and the growth of a software as a service market. We've mentioned how this can be used along with techniques such as service-orientated architecture to create new services or innovations. We've put together a framework for how stuff happens, and whilst we've noted that it's complex, there is also an underlying pattern to this. This pattern explains why nothing is simple in management, why you need to use different methodologies at different stages of an activity's life cycle, why outsourcing by function can often have such dubious results, why most things rarely appear as they are, and how our tendency to try and apply simple control processes can also undermine our future. If we want to survive, then we really need to come to grips with the constant change and learn to tackle the innovation paradox between order and disorder. Now, before I start to make some predictions for the future, I thought I'd go for a little wander through some practical steps to consider. If you want to get to grips with what your organization does, then first you need to map out your activities that your organization undertakes. If you don't have a map of your common business activities and processes, you are going to get lost. Next, you need to realize that each activity is at its own stage of the activity life cycle. So color code your maps. This helps because you can then easily pick out those activities that are commodity-like and hence suitable for any outsourcing or, say, service-orientated architecture. It also means that you can more easily identify those activities which are more innovative and early stage. And once you know this, you can use more appropriate means of management, such as focusing on an investment strategy for innovations or using an ROI approach with market estimations for early stage activities. Much further down the line, you might wish to consider how life cycle is best reflected in organizational roles and how different techniques can be used at every stage of life cycle, from innovation to commodity. Simply being aware of these four things, mapping your business, being aware of life cycle, thinking about componentization, and thinking about organization should help prevent you from making the most common mistakes. So let's get back to the future. As we develop architectural skills and become more used to mixing outsourced activities through a growing market of software as service providers into our own service-orientated architectures, then our ability to quickly and cost-effectively release new innovations should increase. We should see a more rapid rate of new service and product innovations. Hence prediction 1, an increase in the rate at which innovative services and products are released to the web. As companies adopt software as a service, in order to reduce non-strategic costs, we will see a lowering of the barriers of participation in some industries, resulting in a growth in small startups and competition. Hence prediction 2, more disruption in the information market. As these software as a service markets develop and we become more adept and successful at managing common activities, whether processes, sub-processes, products or services, there will be an increasing pressure within IT to apply simple control mechanism across all activities. At the same time, there will be an increasing demand for more innovation. Unless we can solve the innovation paradox, IT will be pulled in two polar opposite directions. Hence prediction 3, increasing organizational pressure within IT. Lastly, whilst we use these architectures to increasingly manage our organizational activities, it should be remembered that all activities are in constant flux from innovation to commodity, despite what any vendor might try to convince us of otherwise. Our activities will constantly change in lifecycle, and hence our architectures will constantly change as well. Hence prediction 4, the enterprise architecture will never be completed. So that's my 4 predictions. An increase in the rate at which new services are released, more disruption in the information markets, increasing organizational pressure on IT to control and be innovative, and lastly, the enterprise architecture will never be finished. For IT, I'm afraid the swirl is going to get faster and faster. And unless we learn how to manage this complexity, then it's the underlying processes that have got it in for us. Thank you.